Hello, I'm Matthew Macario from chemistrymadesimple.net. Today we're going to talk about isotopes and atomic mass. We're going to define what are isotopes and how they affect the atomic mass number that you see. So if you recall from our previous video where we talked about the atomic number and the mass number on the periodic table, we mentioned that the mass number is not usually a whole number. And for iron here, we see it's 55.8. So that number is supposed to be the total of neutrons plus protons, but obviously that would be a whole number, so why are we not seeing a whole number? And it was because of isotopes. So we're going to carry on from there, and we're going to talk about what isotopes are. So isotopes are atoms of the same element with different numbers of neutrons. And therefore we get a different atomic mass for each isotope, or for atoms of each isotope if you want to consider it that way. So we consider all the stable isotopes for a particular element when calculating the overall atomic mass, the average atomic mass for that element. So for our example of iron, iron has an isotope of iron 56, also iron 54, iron 57 and iron 58 are all stable isotopes of iron. So let's consider iron 54 first. So we can see the 54 means that the mass number is 54. That means for this particular isotope there are 28 neutrons and 26 protons. The abundance is 5.8%. Let's just talk about what that means for a minute. That means out of a sample of iron, 5.8% of all the atoms of the iron present will be iron 54. So moving on to talk about iron 56. The 56 means that the mass number is 56. There are, of course, 26 protons in this atom and every atom of iron, but 30 neutrons in atoms of the isotope iron 56. So we can see there is a difference in the number of neutrons here, and therefore that's why we've got a difference in the mass number for these individual isotopes. Now, iron 56 is the most common isotope of iron. It makes over 90% of all iron that we come across. Let's think about iron 57. So, carrying on with what we've already considered, we can see that 57 is the mass number. That means there are 31 neutrons present. And iron 57 is not as common by any means. There's only 2.1% of iron atoms are iron 57. We'll see why that's important in a minute. And iron 58 finally has a mass number of 58 and therefore 32 neutrons. The abundance is again much smaller. There's not much more than a trace of iron 58 in a sample of iron. There's less than 0.3%. Now overall, if we do some calculation, we will come out with the overall situation that for iron in general, the average mass is 55.8 to one decimal place. So that is why we'll see this figure shown as the atomic mass on the periodic table. So how do we come up with the fact that iron has an overall mean atomic mass of 55.8? Well, this is the average of the atomic masses multiplied by their abundances for each of the stable isotopes. So here, because we have iron 54 with an abundance 5.8, we have 54 times 5.8. The same for each of the other three isotopes we see. And we divide by 100 to take that back to normal numbers, not percentage again. If you want to know more about that, you can of course contact me or come to chemistrymadesimple.net and ask the question. We have a lot more resources there. So which topic would you like to see a short video on next? You can DM me on Instagram at chemistrymadesimple. and please take a moment to subscribe so that you can see future videos like this and other resources that we're creating for you. So on Instagram, Chemistry Made Simple, YouTube also Chemistry Made Simple, and on the internet, chemistrymadesimple.net. I'll see you there soon.